Now we'll derive an expression for capacitance of a parallel plate capacitor. Okay. See, these are the two thick plates are separated by a distance say d. Okay. We give a charge for this capacitor by means of by connecting cell to it. So, cell potential difference and the potential difference between the capacitor plates are equal, that is V. The charge on this plate is plus Q and charge on this plate is minus Q. They are equal and opposite, we know. So, here electric field will be uniform because we have studied from Gauss's law. Electric field produced by a sheet is uniform electric field. So, electric field at any point inside is same. At the edges you may have fringing effect and the field lines may be curved here. Okay, if these two plates are placed very close to each other, then at any point you select inside, for that point the size of the plate is infinity. So, infinitely charged sheets produces uniform electric field, that we know. So, electric field will be uniform here. Okay. Initial electric field say E naught. Okay, na initial potential V naught. Okay. Now, I would like to calculate capacitance of this capacitor, parallel plate capacitor. Okay, that will do it. First, I will take this is the first region, this is the second region, this is a third region. We will see what is the electric field in region 1. In region 1, if we select a point, here I want to calculate electric field. From our basics, we know where we want to calculate electric field. There I have to place a unit positive charge. This unit positive charge is repelled by this plate. So, the electric field due to positive plate will be in this direction, and a negative plate attracts this unit positive charge in this direction. This is electric field due to negative plate. But we know from our basics, if charge resides on only one surface, electric field is sigma by 2 epsilon naught. Their distance is not there because electric field produced by sheet is uniform. It is independent of distance. But here the point is close to positive plate, far away from the negative plate. Even though electric field at this point due to positive plate and negative plate is same, because these are producing uniform electric fields. Magnitude of electric field is independent of distance. That's why these two gets cancels out. So, electric field in region 1 is 0. Similarly, in region 3, if I want to calculate electric field here, I will place a unit positive charge. Negative plate attracts electric field due to negative. Positive plate repels electric field due to positive. So, net will become 0. Okay. That means field does not exist outside the capacitors. Field lies only inside. If you see in region 2, if you place a unit positive charge here, positive plate repels E plus, negative plate attracts E minus, both are in the same direction. So, net electric field in region 2 is electric field due to positive plate plus electric field due to negative plate. So, electric field in region 2 is sigma by 2 epsilon naught for one plate and sigma by 2 epsilon naught for another plate. Here see charge is residing only on the one surface, even though it is a thick metal, second surface contribution is 0. So, that is why here I have taken sigma by 2 epsilon naught only. You have to remember this carefully. Electric field E is equal to 2 sigma by 2 epsilon naught. You will get sigma by epsilon naught. Okay, electric field E is equal to sigma, we know Q by A. So that's why this is Q by epsilon naught A. This is since sigma is equal to Q by A. Okay. We know the relation between electric field and potential, that is E is equal to minus dV by dx. Electric field is a negative potential gradient, but in uniform electric field, we have discussed a special case. In uniform electric field, E is equal to V by dE. So that's why we know that electric field E is equal to V by D. Okay, V is equal to ED. V is equal to E into D. So if we substitute E value here, then V is equal to Q by epsilon naught A into D. So now I will write this expression in terms of Q. Q is equal to epsilon naught A by D into V. Charge Q is equal to CV. We know that Q is equal to CV. If we compare these two equations, then C is equal to epsilon naught A by D. So capacitance of a parallel plate capacitor is epsilon naught A by D. Capacitance expression for parallel plate capacitor is C is equal to epsilon naught A by D. See, capacitance do not have charge and potential difference here. Capacitance is independent of charge and potential difference. Capacitance depends on dimensions of the body. That means area of the plate. For example, if you take a plate area means plate will be of two dimensional, we know. Length into breadth. In case of rectangular plate, if it is a square plate, A square. If it is a disc, pi r square. That means the dimension of the plate is one of the factor for capacitance. Second one, distance between the two plates, D. And the epsilon naught is medium between the plates. Here we got epsilon naught because here medium is air. Epsilon naught is permittivity of free space, air or vacuum, we know. So that means capacitance of a capacitor depends on three factors. One is intervening medium, second one is dimension of the plate, and third one is the distance between the plates. Now we will see one by one. For example, for this capacitor, initially air is existing. Okay. See carefully. Potential difference between the plate is V because it is charged to a charge plus Q and minus Q by using a cell. Cell potential difference is V, that only will be stored here. Potential difference between the plates is V. Its initial capacitance is C. Initial electric field is E. Now, if we place a dielectric material, mica or something, if we place, positive charge lies here, inner surface of the plate. Here we have negative charge. This charge induces to the dielectric material. We know induced charge is equal to minus inducing charge into 1 minus 1 by K. From this expression we know dielectrics always induces less charge than what it have. So that's why charge will induce, but that value will be less than plus Q. Okay. For example, this positive plate induces negative charge. A small amount of negative charge is induced. Negative plate induces small amount of positive charge. Here electric field is from positive plate to negative plate. Okay. But now inside the dielectric, electric field will be in opposite. This is induced electric field. Okay na? That means net electric field now is E minus EI. Electric field decreases. Electric field decreases means potential also decreases. Okay. The net field will become E by K. Similarly, potential becomes V by K. Okay. See here, nothing is connected to the capacitor. That's why neither increase in charge nor decrease in charge takes place on the capacitor plate. Charge remains constant. charge remains constant. So now I will calculate the new capacitance. For example, initial capacitance is C is equal to epsilon naught A by D. Now new capacity you have to calculate. Okay. See, we know from expression Q is equal to CV. Okay. Charge remains the same, but potential now becomes V by K. That means the new capacitance is C dash. If you simplify, you will get C dash is equal to Kc. Okay. That means, see here, entire medium is filled with air, so that's why epsilon naught is there. Now medium of dielectric constant K is completely filled. Then we can write this is epsilon into A by D, and epsilon can be written as epsilon naught K. So that's why K into epsilon naught A by D, then we'll write it is Kc. So if the entire space between the capacitor plates is filled with a dielectric, then its capacitance increases, Kc. If the space between the plates is filled partially, for example, then what will happen to its capacitance and all we'll discuss in competitive classes. Next, area. If area of the plate is large, obviously capacitance of the capacitor also becomes large. But large area plates usage is practically difficult because we need nowadays devices are so compact. So the influence of area is only problematic, but increasing the area of the plates we may not prefer to increase the capacitance of the capacitor by increasing the area of the plate. Okay, next one. Capacitance is inversely proportional to distance. That means if the plates are placed close to each other, capacitance increases. Distance decreases, capacitance increases. That's why we'll place one plate over the other. If they place one over the other directly, recombination of charge takes place and the charge leaks out. So we cannot store any charge. That is only the reason why we will say these two plates are separated by dielectric medium. That dielectric medium may be a simple paint,